and she's gonna have like 5 videos to watch. Poor thing. All right. We have our calculators out, so Miles, get yours out, and let's see what we can do with it.
Like no room.
I push. You can turn it over.
No, like not on the back.
We'll get it on another piece of paper. I pushed a car, and I pushed a real car 2 centimeters. That's pretty good. If you ever tried to push a car, you know that's pretty good.
Put it in neutral.
Can I tell a story?
Yes, please.
So,
We definitely need a story.
Aaron was,
Oh my gosh.
Aaron was in the car. So me and Megan last year picked Aaron up. And it was winter, in the middle of winter, it was freezing.
We were in our chapel
Megan's car
uniforms.
started acting crazy, so she pulled into like where Fortunato's is,
On that hill.
up the hill, and like she puts on the emergency brake,
It is sliding.
and
You
then
can get up the hill.
it
stopped.
stopped, and then she calls my dad, and is like, "What should we do?" And he's like, "All right, have Brennan go out and push it up the hill." And so because
I would not stand in back
he
of that
didn't
car.
understand like that we were actually on a hill.
I
He
didn't
thought
think
we
so.
were like
Flat.
flat on solid ground, and so I go behind. She takes off the brake, and the car starts rolling back.
Started
to
going
me.
back, and he's like, "Stop! Stop!"
Oh my
And
goodness.
then Megan started crying.
And,
And then-
Dramatic.
And I was
and it
just
ended
sitting.
up.
I was just sitting in the back, all by myself.
And it ended up. It was just because she didn't get gas, and
Oh, you were out of gas?
Because the gas gauge is like off.
So it wasn't the ice at all?
No.
Okay.
So that
Oh,
was
that's right.
not a good morning.
No.
One time
Alright.
we ran
I
out
pushed
of-
the car
we
2
ran out of
centimeters
gas
and I did 300 joules of
We had a
work.
bunch of cheerleaders pushing 12 passenger in.
How much force did I
Did it
use?
work?
Yeah.
I pushed a car 2 centimeters and I did 300 joules of work. Find the force that I used. Here's some formulas we'll need for this section.
I've seen the one in the I haven't seen the video on
Oh.
PLLs are so intense, pretty lawyers. They're so good.
There's some more formulas, but that's what we need for a while.
Just Pal, stupid question. How many how many centimeters are in a meter?
100.
100.
Centi, 100 cents in a dollar. So. Find the force that I applied in this situation. All right,
Hold on.
I'm going to begin it, so hopefully you can finish it before I do. I'm going to use this formula. Work is 300. We have to change that to meters.
Crap.
0.02. So all we have to do is find the force by dividing by 0.02. And when I did that, I got 1.5 times 10 to the 4th. And that is in newtons. Did you get that? Anyone? All right.
Yeah.
If you did, you can cross out G5.
Oh, 2 away from bingo.
I'm one away.
I'm 1 away in 3 places.
Yeah,
I'm
we're gonna
I'm
get
so
bingo.
frustrated. I'm 1 away in 2 places. That's what I'm
Sounds good. Is that clock right? We got a nice amount of time. All right, now we're gonna do one of the roller coaster problems. So, keep switching to green. I forget. Draw a roller coaster. At the top, there's a cart, 42 kilograms. We'll call that point A.
I just heard it for like the first time.
The hill is 4.2 meters.
I don't listen to it.
Point A and point B is 100. I'm sorry, 1.8 meters. And guess what I'm going to ask? Find the velocity at B. We're going to say that it starts at rest on this problem, but we're going to change that. It's going to start at rest. So we're working on the yellow problem. A cart, 42 kilograms, is at rest on the top of hill A, which is 4.2 meters high. When it gets to part B, where it's 1.8 meters high, find the velocity at B. Start by finding the total energy. Let's do this in parts. Find the total energy for the first X. Part one is always the same. Find total energy. We discussed earlier to find the total energy when an object is at rest, all the energy at point A is potential. So all we need is an mgh. And that mgh is going to be calculated at point A. So I'm going to throw in a 42, a 9.8, and a height. Tippy tap.
Do you want it in sig figs?
Certainly.
Okay.
I don't think I calculated this one. I'll have to borrow from your answers. Someone have an answer for us that we can bounce ours against? Hannah?
I got 1700. That's what I got.
All right, 1.7 times 10 to the third. And because we're looking at an energy, that is a joules. 1.7 times 10 to the third joules is the total energy. It's not the answer to this problem, but it is the first step. If you got the first step before I did, you may cross out.
I3 again.
Yeah, I3 again. I5.
Now I'm one away in 4 places. One away in 3 places.
All right.
Bingo.
All right. We'll keep playing and get a couple more bingos. So, Abby, mark that on the top.
They were all passed out.
Abby, mark that on the top. You got one bingo. We'll keep playing, so Abby, you can get bingo another way as well. Cool. All right. All right, step 2 is to come over here at point B and figure out the velocity. So we're going to do that by recognizing at point B, kinetic energy, total energy equals kinetic energy at B plus potential energy at B. I'll write it the other way since I used to. Potential energy at B plus kinetic energy at B. All right, that is the key to finding the velocity at B. So we're going to remember that the total energy is already been calculated. I'll put 1700. So mgh at B plus 1/2 mv squared at B. I'll let you go from there. So your job is to find the velocity at B. We calculated total energy already in step 1. And now you just plug in chug.
I am so confused.
What is it?
I have a question. Isn't MGH? Oh, that's different because height's different. Okay, never mind.
Yeah, at
Give me
B.
a
We're at
second.
B. We're at B
Yeah.
now, so it will be different. Does that clear it up?
Yes.
Okay.
Then you have to get me.
I got an answer, but I don't know how I did without knowing total energy. I don't think I got the right answer.
Can you give another?
Are you still tapping?
Yeah.
Okay. Tap a little longer.
Yeah, I always do that wrong. Okay.
Do you remember how we did all of these over and over? Before we had a yellow sheet and we did them and did them and did them. This should bring it back. You'll have to do these on the test. So study your little review sheet here.
Okay.
All right. I got, and this is probably wrong because I never calculated total energy. So how did I do it? I got 6.7.
That's what I
have
got.
6.8, but yeah.
All right.
Yeah.
All right. I must have done it by magic. All right, meters per second. It is a velocity. So did you get 6.7? By putting in the mass, the regular mass, which was 42, 9.8, the height of B, 1.8, 1/2, the mass again. And then you have to solve for V sub B. The last step is a square root. All right, if you did that correctly, you would have got 6.7. So there's not many left here. No wonder we're getting some bingos. B2.
Oh my goodness. Why aren't you make that 5 times?
All right.
Same.
We're going to do the same problem again, but this, how we doing, Aaron, for time here?
We should probably stop and
Okay,
then
go ahead.